Hi all, welcome back to another lecture of DBMS, and in this lecture we will see intention and extension topic. Along with that we'll see database schema versus database state. Then we will learn about 3 schema architecture, and then we'll see the more topics like data independence. Out of these there are 2 types of data independence: logical data and physical data independence, and what are it means. So let's start with the very first topic of today's session. So the topic is database intention. So intention refers to a given relation which is independent of time, and intention defines all permissible extensions. It is a structure of schema of a database and defines the design of database. So basically database intention is nothing but the actual entities, but it is independent of time, right? So how basically it looks like, so let's suppose we have a transaction table, customer table with their own attributes, and product table with their own attributes. So this is called the database intention, where we are not defining the data as per the exact time or the actual data. But in case of database extension, it refers to the state of all records appearing in a database at a given time. So it shows the actual data, actual records, actual rows and columns values also, and that too at a particular given time. So it refers to the actual data stored in database at any given time, and it represents the state of the database and the collection of tuples present. So basically all the exact data at a given time, when we show, it is called data extension. But when we just show the, or when we can see the transaction table and customer, basically the entities without the actual data and also independent of time, we call it as database intention. So that is a basic difference between database intention and database extension. Now let's see what is database schema and database state. Schema is nothing but, from the name itself you know that schema is nothing but it's a structure, right? So it represents a logical view of a database and the table it consists of. So schema represents a logical view of the data. It defines how data is organized, the relationship between them, and constraints that might exist. So database schema defines how data is organized. Instead of actually storing the data in the physical memory, we just show how the data can be exist and what can be the relationship between those two entities. Schema diagram depicts the illustrative display of the database schema, and it is also called intention. So basically intention, the database intention which we have seen just 2 slides back, that is the actual or logical representation of the data or the relationship between the entities, not the actual data. But when we talk about database state, state is the, as per the the database view at a given time, at a given time. So it represents the actual data stored in the database at a particular state in time. That is why it is called database state. Database state includes a collection of all data in the database. So database state, it includes the collection of all data. So it actually shows whatever data, like in the form of relational database, which is row and column values, it will show all the values at a particular time. That is why it's called database state. It also known as database instance or occurrence or snapshot, because snapshot basically whatever data is present whenever you are taking the screenshot, right? So for that time you have taken the screenshot. So for that time you have all the records or values present in the RDBMS. You can see that, right? And that is why it is also called database extension. So this is what database schema is: a logical representation. It is called intention. It is totally independent of time, but database state is dependent of time. It shows the actual data instead of structural or logical view, and that is also called database extension. Now, what is 3 schema architecture? So we have already seen this in last lecture, I guess, where 3 schema architecture, basically the whole design of the database from physical level to the view level for the customer. We divide these levels into 3 different parts. Very first is internal schema, which is physical level, and here is a physical level and where we actually store the database, right? So example, B tree or indexing. Then comes a conceptual schema, and this is called middle one, and the logical view. So here we don't actually save the data, but we just see the overall structure of the database for the entire organization, regardless of how data is stored, because that is taken care by the physical level. Logical level only says the relationship and the actual structure of the database, how it should look like. And third is external schema, that is called view level, and where it is the highest level of abstraction, and it can be only viewed by end user. So end user interacts with this instead of exactly knowing how the data is being stored in the physical level. It just interact with the view level with the GUI, and it hits either API or SQL query it will write to fetch the data, which we have already learned in our previous lectures. So highest level of abstraction and defines how end users use the data. This can be tailored to specific user groups with different views for different departments, right? So user can view the data as per their requirements. So let's say we have a table, we have name, age, phone number, address, orders, etc., right? But we as a if let's suppose we are a user, and user 1 only want to see the name, age and phone number, okay? They don't want the address or other parameters, attributes. So user 1 can give the query and can only view the that much part of data what they want to see. If user 2 want to see the whole data, they will give the query. According to that, they can see the whole view of the whole data. So basically that's what it's saying. This view can be tailored to specific user groups with different views or different departments. So as per their needs, they can see that much part of the actual data. That is what 3 schema architecture means, and how what all levels of the schemas defines their properties. Now next is data independence. So from the name itself, you can see independence means that are not dependent on another data, right? So data independence is a property. It is a property of DBMS system which allow modification of database schema. So this property allows modifications in the schema at one level. Okay, so we have seen the 3 levels: physical level, logical level and view level. So at any one level, if you are doing any change, that should not alter the schema of next higher levels, right? That is what the meaning of database independence. So in this whole database, there is physical level which actually stores the data, logical which just give the structure or relationship between the entities, and view level where the end users interact to actually see the data. So this is the external, conceptual and internal schema. So in those 3 schemas, for anyone, if you are doing the change, that should not violate, or you can say alter another schemas. So change in the database structure do not affect the application programs, or like if you are changing in this physical level, it should not impact the application program or user view accessing, providing flexibility to the ease of maintenance. Now how we can change it? Let's see. So very first type of data independence is logical data independence. So let's suppose we have done some changes in the logical part. Is it going to change the view part for the user or not? Let's see. So ability to change the conceptual schema, logical structure basically, without requiring changes to external schema, that is user view or application program. So basically, let's suppose here we have an address entity. Address attribute. Okay. So address, you know that address consists of street, pin code, city, state, and all those things, right? So in the logical view, if you feel that logically you can just make the attributes different instead of one address, you can give it street, city and pin code or state. Okay. So you have differentiated these attributes compared to the previous one which you were giving at a single place as an address. So if you have logically changed it, does this affected the view logical does this affected the view for end users? No, right? Why? Because address can again be formed by concatenating all these 3 attributes. So that's what it means. So for user view, it remains consistent as a system can still return a composite address, right? By joining this street, pin code and city. So no change to user interface or application required. So in this, if you have changed the logical thing, it has not impacted the user level thing, right? So we're just going to see the next higher level. So that is the example of logical data independence. Now let's see the physical data independence. So basically, this talks about the ability to change the internal schema, like in the physical storage, like how we store the data. If we are doing the physical storage change, does this, going to impact the upper two levels or not? Now let's see how. So without requiring change to the conceptual schema or external schema, if we are able to do the internal schema change, then it is called physical data independence. Let's see. So let's suppose in the physical storage, you have saved your data in such a form. Okay. So if database decides to change the data storage form, and earlier it was saving in heap, right? So now it decides from heap, it want to save the records in the indexed file system. So this will not change the logical structure, right? Because the way you are saving your records in the backend part is not going to impact the logical part, logical schema, or even for the user level, view level schema. So it will only affect the performance of queries, but not the logical structure and the user or view level structure. So that is also another example of physical data independence. So that's about the whole lecture, where we learned about intention, extension, what is a database state means, which is basically on the time dependent. Then we have learned about data independence, where we have learned logical data independence and physical data independence. I hope you learned, and that was all about the whole lecture. Now let's meet in another lecture with some more interesting and important topics. Till then, keep learning, take care of yourself and your family too.